All right, how about area and length? So anytime you come across area and length problems, remember you get this from reading all the way through and getting the overall flavor of the question. You go, this is talking about area, so I should probably draw a picture and think about length times width, and if it's triangles, remember Pythagorean theorem and basic geometry and trigonometry, right? So it just gives you an idea of where to begin when you have to start solving these things. So here's a typical type of question. And I mean typical. You will see these types of questions time and time again. So once you learn how to solve one of them, the steps are the same. All you got to do is change the numbers and slightly change your picture maybe. All right, square garden, walkway 3 feet wide around the outer edge, as shown in the picture below. If the area of the entire garden, including the walkway, right, that's important. You gotta read the words, including the walkway, that's important, is 18,000 square feet. What are the dimensions of the planted area? All right, so we've identified our question. What are the dimensions of the planted area? So we're basically looking for length and width, right? What are these two dimensions? Of the planted area, right? Of the dirt, not including the walkway. All right, well, we've read all the way through. We've identified our area, right? We're looking for the dimensions. Remember that because this is a square garden, these two things are the same, right? Length and width are the same. So that's why we can just go ahead and call it x. Now, they tell us that there's a 3-foot walkway, so we can label this as 3 as we go through here, blah, 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 blah. The area including the walkway is 18,000. So doesn't that mean that if I take this whole length here and square it, it's going to be 18,000, right? Because remember, it's a square. So this distance up here is x, and then you've got 3 feet here and 3 feet here. So isn't that total length going to be x plus 6? And isn't this going to be exactly the same, right? Here's x, there's a 3 up there and a 3 up there, so it's also going to be x plus 6. So we're going to square that, and that has to equal 18,000. So you can FOIL this out, or if you remember your formulas, you know this is x squared plus 12x plus 36 equals 18,000. And now you have to solve that. Well, you recognize that as a quadratic, and you go, you know what? I can solve a quadratic very easily with the quadratic formula or by factoring, right? There are other ways you can solve it. You can solve it by grouping and things like that. And we're going to show you some other ways on the other slides. But the easiest way is to solve it as a quadratic. So if you know how to solve a quadratic, you're good to go, right? You have to bring the 18,000 over because you always have to set a quadratic equal to 0. So you get x squared plus 12x minus 17,963 equals 0. And now you can try to factor it, x, and you're basically looking for factors of 17,963 that have a difference of 12, right? Or sorry, add to 12 because it's they have to have a difference of 12, right? Because this is a negative number. So one of these is going to be negative, one of these is going to be positive. Obviously, the bigger number is positive because you have a plus 12 here. All right, let's see how else we can try and tackle this one. So far so good, just like what I did, x plus 6, right? Set it equal. Well, instead of setting it up as a quadratic, we could just take the square root of both sides. And this might make our math a lot easier. So whip out your calculators if you got them, and take the square root of 18,000. See, well, you don't get a whole number, that's for sure, right? That's not a perfect square. But you can work it that way if you want. And so x is going to equal, it's 134.164 minus 6. So it's basically, when you round, about 128. You can get a more precise answer if you want, but for what we're going to be doing, that's going to be good enough.